This is a lesson for Chapter 4, Section 1, and we're looking at using graphs to relate to quantities. So the first set of directions asks, what are the variables in each graph? Describe how the variables are related at various points on the graph. And so first of all, our variables are always going to be what the x and the y-axis represents. So x is typically our variable that we use in a lot of problems. Well, the x is the time value in this case, and the y represents volume. So our variables are just going to end up being volume and time in this case here. Now it asks us to relate or describe how the variables are related to the various points in the graph. Well, whenever I see a straight line, that ends up telling us that we have a constant rate of change. And so as the time increases, so as we go out this way, this is the increasing side, because this is numbers like 1, 2, and so on. And then as time increases, volume's getting larger too. So you see how the numbers are getting bigger in this case here. So I'm going to use this symbol here for increasing, and I'm going to use a line, an arrow going down for decreasing. And so as I see the volume, we could say, the volume increases as time increases, is what we end up seeing on that one. Over here it says the temperature of water, and we have our first of our variables. And so our variables in this case are going to just be our x and y axis, what it says they are. So it's temperature and time. So as I look at it, I've got another straight line, but this time it's a decreasing line. So what that means is temperature is decreasing. So as temperature decreases, or depth, oh, not time this time, I didn't look down there, it's actually depth. So let's erase that part. So let's change the other variable to depth. So as temperature decreases, depth increases. So it's a negative slope we're going to learn about. So whenever we have a positive, that would mean a positive slope. A positive negative or a negative positive would indicate a negative slope. So over here, our variables are just going to end up being the x and y axes. So we have plant height, and we end up having time. I was a little more careful this time as I looked at that. So time and plant height, those are our variables. And then we want to describe what's going on. Well, as time increases, plant height increases as well. So on this next set of directions are kind of, you don't really see what it says, but it tells us to match the table with the graph. And so we've got these 4 graphs, and we want to match the table to it. So what I want to look for is, I want to look for a line. See how this is a nice straight line? You can see it is nice and straight because it's got a constant rate of change. See over here, the variable distance is increasing by 50 as the time increases by 1, and that happens every single time. And so we see that this is a constant rate of change. And so over here we see the same sort of thing. I see this one increases, and it appears to be constant. It's kind of hard to tell because the numbers, it's not lining exactly up on one of these intervals, but it appears that this is also a constant rate of change. As time increases by 1 hour, distance is increasing by somewhere maybe around 60-ish or so, or maybe just 50, somewhere in that range. It looks like a little bit more than 50, probably about 60 or 70 or so. So let's go ahead and take a look at what we've got. So on our tables, they give us the same variables. They give us time and distance. So this is our x-axis, and this is our y-axis. And so they're giving us that for 1 hour, it's 60 miles. For 2 hours, it's 120. So if it's a constant rate of change, what we're going to end up seeing is an amount of hours or miles is going to increase at the same rate as the time does. So it's increasing by an hour here, and if I add 60, I get 120. And that's increasing by 1 hour. And let's see if it does the same thing. So since I'm increasing by an hour, let's see if I add 60 to this number, I should get this number right here. And that's what I get. You see, every single time I'm just adding 60, and I get the next value. See, that's called a constant rate of change. And so when we are looking at this, I see that the one that increases by 60, this one only increases by 50 each time. Remember how we said this one looks like it's a little bit more? It's hard to tell because they're not lining exactly up, but it looks like this is a little bit more than 50, and that's what we see here. So this is probably 60 to 1. So I would say that graph 6 here and C go along with each other. And this has a constant rate of change is going to end up equaling 60 miles per hour is what we end up seeing there. Well, on this next one, I look for the same thing. I look for a constant rate of change. And so I look at these two, and this is 80 miles. So 1 hour, 80 miles. And that actually gives it away which graph it is right now. Because you see, after 1 hour, we've gone 80 miles. And so that matches this point right here. And so this point matches it as well. So 2 hours, you see it's a little bit over 120. Let's see if it's what's happening here, though. You see how here we increased by 80 in this 1 hour. But when I go ahead and add 80, you see that makes 160. So not exactly this number. So it's not increasing at the same rate if we started from 0. You see, if I drew this line in here, they're not at the same rate. And you can see that again over here. If I'm at 125, and we'll go ahead and do it a little bit differently here. I'll subtract these numbers. So if I took this 80 and I subtracted 80 from the 125, that gives me 20 plus 25 would be 45 in order to get there, and that gives me that 125. But then when I subtract these two numbers, if I add 45 to this one, that doesn't give me this value. It gives me 170, and these two numbers are not the same. So this doesn't have a constant rate of change. And so it's definitely not a line, and this shows that it's not a line either. So I would say 5 and B go together there, where 6 and C. And so this one should be A, and so let's see why. And so if I look at the hours, 1 hour to 50 miles, and that does match this, and then if I add 50, I end up getting 100. See, I'm getting this number. And so that's what you're going to end up seeing with constant rates of change. If you always add that rate of change by the next y value, you should get the following y value, and that's what we end up seeing here. So if I add 50 each time, I end up getting that following y value because the hours are just increasing by 1, the miles are increasing by 50. And so that's what we see here. So the constant rate of change is 50 miles in 1 hour. So let's take a look at some other problems that we'll end up seeing. Here it says, sketch the graph to represent the situation. Label each section. Okay, so you buy 2 shirts, and the third one is free. So what we've got here is we've got a graph they want us to draw. So there's my y-axis and my x-axis. And I'm going to call the x or the y-axis cost. And I'm going to call the x-axis what makes the cost? Well, it's the number of shirts. Number of shirts. And so if I say that I buy 2 shirts, okay, so they cost something. And notice how I'm going to end up having a straight line for the next one because they're going to cost the same, we'll say. So these are definitely costing the same, but the third one is free. Well, that means I still pay the cost of the second shirt, but I don't pay any more. So you see how those two are in line. So that's going to be the same cost. 2 shirts cost the same as 3 shirts there. So let's take a look at it. The next one. It says you warm up for gym class, play basketball, and cool down. So we're going to have, let's take a look at what would change here. So we've got, first of all, time along the x-axis, and what changes when you play basketball and then cool down would probably be like your heart rate. So the heart rate is going to change quite a bit. So when we warm up, maybe it's starting right here, because we've got to have some sort of pulse. If we were 0, it would be dead. So we've got to start somewhere, and maybe we warm up and our heart rate increases a little bit. And so this is the warm up right here. This represents the warm up. Then we start playing basketball. So that means that our heart rate's probably going to go up a little bit faster. So it's probably going to do something like this. And then we'll probably reach a certain point and then probably level off and kind of maintain that fast heart rate for a while. So as we play basketball, it increases at first, but then starts to taper off, still quite higher than it was before. But then we start to cool down, and we're going to end up decreasing our heart rate. So for the cool down right here would be represented by this line at this stage. So here it says the temperature warms up during the day and then decreases at night. And so we'll go ahead and sketch a graph in here, and we've got time as the x-axis and temperature as the y-axis. And so I'll start off with, it warms up. Well, the temperature, let's say, has some sort of, we've got a temperature right here, and then it warms up during the day, so it's going to slowly increase, and then it's probably going to stay somewhat constant or so for a little while, and then it's going to start to cool down. And so that's what we end up seeing. So it warms up during the day, and then it kind of stays constant for a while, and then we see it decreases at night. And so that's what this line represents. So we're looking for an error here. It says DVDs cost $19.99 each for 2 purchased. Okay, so 2 purchases cost $19.99 each, and that's kind of what they're showing here. So one DVD costs pretty close to $20. The other one, well, it's going to be like $39.98, so pretty close to $40. And then after that, the cost is just $5.99 each. So what they did is they drew a line down here at $5.99. So they're just a little above 5. But the error is this. This shows that for 3 DVDs, you're going to only pay $5.99, but that's not the case. So the error is that 3 DVDs cost $5.99, but you're not going to pay $5.99 for 3. You're actually going to pay, that $19.99 plus another $19.99 and then plus $5.99. So when you add all that up, that makes $45.97 is what you're really going to pay. So $45.97 for 3 DVDs should be right, let's say it's going to be a little above that line, so somewhere right in this region here. And so the line should end up going like that. And this part would be wrong there. Now, they do draw lines to kind of give you the visual effect a little bit about how things are going, but truly, you really only have, you can't buy a part of a DVD, so really the points would suffice. The reason sometimes they draw lines like this is just to make it a little bit more visually appealing, so you can kind of get an idea about how things are changing, their rate of change. But truly, these lines would not be needed because you can't buy a part of a DVD again. So let's take a look at the last one. And what it says is that we have to sketch the graph for the situation. Our graph's the same, and explain. Your distance from school as you leave your house and walk to school. Okay, so let's go ahead and sketch that in. So this is part A. And we've got time on the x-axis. And time is always going to be on the x-axis because we're going to find out later that this is our independent variable. And our dependent variable would be better situated on the y-axis. And that is the distance from school. Distance from school. or actually, let's see here, they're asking for your distance from school as you leave your house. Okay, so distance from school, yeah. Okay, so distance from school, if this is the distance from school, it's going to be up here, not down here, because it's distance from school this time. So we're going to go toward school. And so if we walk at a constant rate, it doesn't say that, but let's say we do, we walk at a constant rate, it would do something like this. We'd continue at school, and we walk and walk and walk until we're at school. And then that would be the graph. And so we have a graph that just kind of descends downhill as long as we're walking, we'll say, at a constant, we'll say walking at a constant rate. But then part B says, well, your distance from school as you leave school and walk to your house. Okay, so we have time, and again we have distance from school, and try to fix that y-axis a little bit, make it a little bit straighter. Let's see if I can do that here. That looks a little better. Okay, so we are now at school, and that means when we're at school, we are distance from school. If we're at school, it would be right down at the origin. And then as we walk home, if we walk at that same rate, or maybe a little slower this time it looks like, we're going to end up there. And notice that's going to be the same distance as we were when we started the day. And so this is different in that they're not the same. And the reason is we can say that no, one decreases because distance from school because we're the distance from school, and then when we're at school, one decreases because it's the distance from school, and that's this one here. And when we are at school, we start the graph at the origin, and then it increases. So the graph increases because we are going away from school and we're going back to home. So that's what we end up seeing in that situation. Well, those are the types of problems we'll see on the homework. Good luck.